us what is differentiation?
From what I know, differentiation is basically a branch of calculus where we find the rate of change of one variable with respect to another variable.
Yes, by differentiating a function, we can also determine the gradient of a tangent line since it is equivalent to f prime x at a particular point.
And then, we can also determine the equation of the tangent line by using straight line equation, that is y equal to mx plus c.
So in this section, we will explain the technique of differentiation. First of all, we have the constant rule. For the constant rule, if we derive a constant, we will get the value of 0. And then we have the power rule. For the power rule, if the function or the base has power, we have to multiply it with the coefficient, and then we have to minus the power with 1. For the sum and differences rule, we have to expand the differentiation into the function, and then we have to derive it respectively.
So I will be explaining the technique of differentiation by product rule, quotient rule, and chain rule. So about product rule is basically where we derive a function, but we use the formula of u plus a u times with v prime plus v times with u prime. For example, we have an equation of y equals to this, and this will be our u, this will be our v, meaning that we have to derive the u to get our u prime. Same goes with this, we will have to derive it to get our v prime. And then for our quotient rule, what we have to do is we derive it by using this formula. This formula we can obtain it from this function where the numerator is actually our u and our denominator is our v. For the chain rule part, this is the one where we have to find dy over dx. And to find dy over dx is quite simple, where we derive dy with respect to u, and u we have to derive it with respect to x, which means our du can be crossed out, and then we will get our dy over dx.
So for my part, I will explain about the derivative of the trigonometric function. So first here we have the trigon is sin fx, and we just derive the sine into cos and derive its angle. The second one here is cos fx, we derive to become negative sine and derive its angle. Third one here we have tan derive to become sec square and derive its angle. So also if we got the power here, we need to apply the power rule, and then we can derive the trigon and its angle. Same goes for this also. So we write it like this after we apply the power rule. So for this way, also we have the trigon is cosec fx. We derive it to become negative cosec cot fx and derive the angle. So the same goes for the others.
For this part, I will explain about the derivative of exponential function and logarithmic function. So for the first one is exponential function. It is given here is that the exponential is our argument. In this case, when we differentiate this, we must copy back the question, and then we must derive its argument. And then for logarithmic function, specifically natural logarithmic function, when we derive ln fx, it will turn it into a rational function where the denominator will be copied back the argument, and then whereas the numerator, we will differentiate its argument. MAT183 class won't start yet. Why don't we try to solve some question to kill the time?
Oh, you're right, let's definitely do that. But what kind of question can we try to solve?
What about we try this passive question?
Question 1a. Find the dy dx for the following function. Y equals to 4x plus 10 to the power of 5 and ln 4x plus 1. So the function is in multiplication form, so we have to use the product rule. First of all, we have to identify the u prime and v prime. To find u prime, we need to use the power rule first, then we have to derive the argument, then we will get the value. And then for the v prime, we derive it generally. So next step is we have to apply the product rule, which is dy dx equals to u v prime plus v u prime. First of all, we have to substitute the value in. After that, we simplify it to the simplest form. And then we will get the final value.
So I will explain on how to solve question 1b. So here we got the equation. First, We start by splitting the fraction into two functions, which is u and v. First, we need to derive u until it becomes u prime. Like here, we got negative 3 sine in the bracket 3x minus 2. For v prime, we got 2e to the power of 2x minus 5. After that, we can apply the quotient rule, which is dy over dx equals to vu prime minus uv prime over v squared. And then, we just substitute the number from above. Next step, we need to simplify by cancelling e to the power of 2x minus 5 from the numerator and denominator. So the final answer here we got is negative 3 sine in the bracket 3x minus 2 minus 2 sine in the bracket 3x negative 2 over e to the power of 2x minus 5. And that is the differentiated form of the function using the quotient rule.
So for our question 2, how are we going to find our dy over dx by implicit differentiation? So here we have our first term, second term, third term, and our fourth term. So for our first term is 10x cubed. So how are we going to derive it? So we have to use the power rule. Power will multiply with the coefficient of our base. So that means our cube, our 3 is actually our power, and then we will have to multiply it with 10. So we will get 30 cubed. And don't forget to minus 1 from 3, so we will get 30x squared. So for our second term, which is 4x sine y squared, first thing first is you have to understand from the polynomial function where 4x is actually multiplied with our sine y squared. So that means we can derive the 4x sine y squared by using the product rule, where we have our 4x as our u and then our v sine y squared. And then from the u and v, you just have to derive it one by one, where u will be 4x, deriving it we get 4. However, for our v, when we want to derive it, we have to derive the trigonometry first, and only after that we will derive the y, and then deriving everything again, and we will have our 4x sine y squared in the form of product rule. For our third term, how are we going to derive 1 over exponential to the power of y? So first thing first is you will have to simplify it into another form, where we will get negative exponential to the power of negative y. And after that, step 2, you will have to copy back the argument and then derive it, where our argument is actually the value in the power of the exponential itself, which is negative y. So when we deriving a negative y, we will get negative dy over dx. And after that, you will multiply it again, which after that you will have to simplify it, and we will get negative 1 over exponential to the power of y dy over dx. Our fourth term, 5 ln 3x minus 1, when we want to derive it, first thing first is you have to understand how to divide the function by the term, where we have 5 multiplied with ln 3x minus 1. So that means we can actually make our logarithmic function into a simpler form. So we will get 5 times with 1 over 3x minus 1, and then you will have to copy back the argument itself, which is 3x minus 1, and then deriving it. As you derive 3x minus 1, we will get 3, and you'll just have to multiply it in just a simple fraction form. Our final step is basically just combining all the terms that we have derived just now back into the original equation. But here, if you look at this page, you will see that I have wrote the original equation by using a black pencil, and then the next equation is actually a rewritten part of our derived term in the blue pen. So write it back and then compare the original one and the new one. Keep in mind that your symbols, negative, positive, keep it as it is, as the one that I have highlighted there in the purple color. And then the symbol will be expand into each of your term, and after that you will have to factorize the dy over dx. After that, you will just have to bring the expression out over to the right side of the equation, and then we will have our dy dx by using implicit differentiation.
Question 3. Use linear approximation to estimate the value of 2 over square root 80.44 plus the fourth root of 80.44 correct to 3 decimal place. First step, copy back the question but replace the 80.44 with x, then find the value of delta x. X will be 80.44, whereas x0 is 81, since the closest number to 80.44 is 81. Then calculate as usual, and delta x is equal to negative 0.56. And then for step 2, we need to differentiate the function with respect to x, and then we will get negative 1 over x to the power of 3 over 2 plus 1 over 4x to the power of 3 over 4. For step 3, find the value of fx0 and f prime x0. First, fx0. Substitute x0 value, that is 81, and solve as usual. You will get 3.2222. And then repeat the same step for f prime x0 and you will get 7.8875 exponent negative 3. For the final step, by using differential method, that is fx0 plus delta x, approximately fx0 plus f prime x0 multiplied with delta x. Substitute all value obtained and you will get 3.2178. And we can recheck our answer by using calculator.